This video is about the fourth type of reaction in Chapter 8, Section 2. This deals with double displacement reactions. Double displacement reactions, you have two compounds, and the ions, the similar ions, in other words the positive ions or the negative ions, and the two compounds simply exchange places. These usually occur in aqueous solutions. Okay, in other words, you'll have two solutions, you mix them together, and this reaction occurs. The compounds that form, generally one is a precipitate, an insoluble gas that'll come out of a solution, will bubble up, or it's a molecular compound, and very often that's water. The other compound is usually soluble and it remains behind in the solution. You have the general equation AX plus BY yields AY plus BX. You'll notice that we start with two compounds here. You have a metal and a non-metal ion. Here, metallic and non-metallic ion. And you can either trade places with the two metals or the two non-metals. In this case, we've traded places with the two non-metals. That gives us AY plus BX. If you should choose to change the positive ions, you would get BX plus AY. It would just change the order here, but it would not change the end result. You still have those two compounds. And so in this, AX, B, and Y are the reactants. A and B are the metallic ions. X and Y are the non-metallic. In other words, A and B are the positively charged. X and Y are the negatively charged ions. AY and BX represent ionic or molecular compounds, as do AX and BY. Generally, most often you'll get a precipitate, and this forms when one of the compounds is either insoluble or only slightly soluble. Now you might ask, well, how do I know? And I'll tell you. You have to go to page 860 in your textbook, and there you'll see a table that will allow you to check these out. And we'll look at this example. You have potassium iodide plus lead 2 nitrate reacting. Both of these, you'll notice, are aqueous solutions. They're dissolved in water. That forms lead iodide as a solid. And if you look on page 860, if you look down the left-hand column and find lead, then look across the upper column to the iodide, or actually it says iodine, but where those two intersect, lead 2 and iodide, you see a P. That P means partially soluble. So this is, it's not insoluble, but it's only partially soluble. So some of it will stay in the solution, but most of it will form a precipitate, and you will see it in some form. Usually that precipitate, sometimes it's a different color, but it will begin to come out of the solution. If you just leave the beaker or the test tube alone, you'll usually find that collecting at the bottom of the beaker or test tube. And this just tells you there's a very strong attraction between the lead and the iodide ions, and that's what forms the precipitate. They are not, you're not able to break those apart by the hydrogen bonding in the water and that pulling those ions apart. Sometimes a gas is formed. Here you see iron sulfide and hydrochloric acid. When those are mixed, here the H, the positive ion here, and the Fe, the positive ion here, trade places. So the H with the S gives you hydrogen sulfide, and iron chloride is formed, iron 2 chloride. And so this is a gas that will bubble out of solution. And then you can also get the formation of water. Here you see hydrochloric acid plus sodium hydroxide. Anytime you have an acid and base, and this is something you'll learn when we get to chapters 14 and 15, acid plus base yields salt plus water. And so in this case, the mixing of these two aqueous solutions, one of the compounds that's formed is water. How is that any different from the water that's already there? It isn't. But if you evaporate the water, you can recover the sodium chloride. Those ions stay in the solution, but this doesn't. And that's all we have for double displacement reactions.